All right, we're back with another review. This is going to be 19.2, Le Chatelier's principle. So Le Chatelier's principle, put simply, is that a chemical reaction at equilibrium, when a stress is applied, will favor the release of that stress. So this first question here asks, what are the three, right? So what are the three stresses that can upset an equilibrium? And so the first one is concentration. The second is, I'll put the brackets in just so that we get in the habit of knowing that brackets mean concentration. One note, and some students had questions. The units for concentration is molarity, which is moles per liter, or moles per 1 liter, just as a refresher. The other two stressors which are introduced here is temperature, and the last one is going to be pressure. So those are the three. Moving on, here is a chemical equation. So you have nitrogen gas and oxygen gas, and it's a 1-to-2 ratio. So 1 to 2 right here, plus adding heat. So this reaction requires you to add heat as a reactant, which means that it absorbs it from the surroundings, which means this is an endothermic process. So this would have a delta H that is positive. So it's increasing in temperature. But the surroundings, so if you were to do this in a cup, the cup would feel cold because it's absorbing the heat into the reaction. All right, and it produces nitrogen dioxide, which is here, so 2 moles. So it says predict the equilibrium that will be favored, forward, reverse, or neither for each of the following reactions. So remember, if you add stress to a system, it's going to favor the side of the reaction that releases that stress. So the first one is going to be adding N2. So if I add something to the reactants, it's obviously going to have more and more reactant, so it will favor the forward. If I remove O2, so that's actually relieving stress on the left-hand side, but that's adding more stress to the right-hand side. So it's actually going to favor the reverse. So think of it kind of like a vacuum. If you create a hole there, the hole needs to be filled. So since I removed O2, that creates a hole on the left-hand side. So that means that more NO2 will decompose to fill that void or that hole. Temperature. So temperature is increased. So if you look at the reaction, not all reactions will react the same to temperature. You have to look at the specific reaction. So in this case, adding heat actually adds a reactant. So remember, just like the first one, if we add N2, then the forward reaction goes. So if I add a reactant, so in this case, my reactant is going to be temperature, right? Temperature increase. It's going to favor the forward. Pressure. So pressure, and I'm going to write a little note, this favors, an increase in pressure favors less molecules. If you look at the document in the reading, you'll notice there's a couple pictures showing that when you increase the pressure, there's less room. So since there is less room, the reaction will tend to favor the side that has less molecules. So what I have to do is, they don't matter the type of molecules really, because they are gas particles. And if you remember, gas particles are so far apart that the only the amount matters. So on the left-hand side, I have 1 molecule of N2 plus 2 molecules of O2. So on the left-hand side, I have a total of, and I'll put this in parentheses, 3 molecules on the left-hand side. But on the right-hand side, I only have 2 molecules. So on the left-hand side, I have 2 molecules. So it's going to favor the side that has less molecules. So in this case, if I increase the pressure, right, it's going to favor the side with less, which would be the forward reaction. And moving on, we have a catalyst. So if you remember, by definition, a catalyst is a substance that speeds up a reaction. So in this case, since it's going to speed it up, it will favor the forward. Just one note, the catalyst is not used up, so it's different than a reactant. A reactant is used up and there's less of it as the reaction goes forward and vice versa. So, all right, NO2 is removed. All right, this is similar to the O2 case, except NO2 is on the right-hand side. And again, like I said, it creates a vacuum. So since it creates some sort of vacuum, it needs to be filled. So the forward reaction will be favored. The last two, the temperature is decreased. So if I remove heat, right? So instead of adding heat on the left-hand side, I'm actually removing it. So I'm making less. So that's creating a vacuum on the left-hand side. So the reverse will be favored. Okay. And then the last one here is the system volume is increased. So just from the gas laws, we know that when volume increases, that means there is more room, right? Therefore, the pressure decreases. So this is actually a pressure question. Up here, if you notice, the pressure was increased. So that would actually make, you would have to make the container, the chamber, smaller in order to increase the pressure. But in this case, it's saying that the volume is increased. So that means there is more space, which means that more molecules can be in the container. So it'll favor the side that has the 3 molecules versus the 2 molecules. So that would be the reverse reaction. Okay, so that's the first column. And what I did is if you looked at the homework assignment from last week, there were 2 other questions associated with this. So there was the concentration of NO2. So that's actually the concentration of the product, what would happen in each of the cases, and then the equilibrium. And just a note on equilibrium, if it's less than 1, favors the reverse. So it's going to favor the reactants. But if it's more than 1, favors the products or the forward reaction. I'll just keep the wording the same. Okay, so that's what we're going to base it on. Okay, so if I add N2, the forward reaction is favored. So that means the amount of NO2 is going to increase, right? If you have more of your reactant, you can make more of your product. Makes sense. O2 is removed. Remember, it creates a vacuum, so it goes in reverse. So this is actually going to be a decrease. And you kind of start seeing a trend. If the forward is favored, then there is an increase in the amount of product, right? But, and this one is also increased, but if the reaction is favored in the reverse direction, then that means in order to make it go into the reverse, you have to use up some of your product so that the concentration would go down. So it would be a decrease here, and it would be a decrease here. All right, so that covers the concentration of NO2. So as long as you did the first column correctly, it ends up helping you solve the second one. So, all right, and then the last one, KEQ. So again, since I know what the definition of KEQ is, it is the equilibrium constant. So again, less than 1 favors the reverse, right? So that's why I used the term reverse, so that we can look at column number 1. So, but instead of saying it's going to be less than 1 or more than 1, you can just say that it increases or decreases based on, what happens in the first column. All right, so you will notice then that the first one, by adding N2, the forward is favored. So that means that the KEQ will increase. And so you're also going to see a trend here that the increase and decrease is going to be very, very similar to the NO2 concentration or the nitrogen dioxide concentration. So the reverse is favored here since I created a vacuum or removed O2, right? So then this would be a decrease. And so on, right? these will all be an increase in the KEQ because the forward is favored. And then these will all be decreases. So your data table will look something like this. Again, you can access this document after I'm done with this video, but just go ahead and review it. Make sure you understand this. All right. The last thing that I wanted to cover was that last question on the homework assignment from last week for this section. So given the following reaction for the formation of sulfur trioxide, so this is sulfur and then trioxide since there are 3 oxygens attached to it. And so the reactants are going to be sulfur dioxide and oxygen. And as you notice, the energy release is on the right-hand side. So that means it is released as a product, which means this is endothermic. So the container that it's in would start to get warm. What conditions of temperature and pressure would maximize the concentration of the production of sulfur trioxide at equilibrium? So I wrote 2 sentences just so that you have an idea of how you should be writing these. So the first one is about temperature. So temperature must either increase or decrease because it is a product, and it would shift the equilibrium to the left or to the right. So since it is a product, it's being produced every time the reaction goes to the right. So if I want to favor the reaction going to the right, I would not add more heat. The reason for that is it would actually create more product, and therefore the reaction would stop a lot faster. But if I create a vacuum on the right-hand side, so if I remove heat, so if I decrease the heat, I'll highlight it right here, okay? If I decrease the heat, then what's going to happen, it'll create a vacuum and it'll shift it to the right, or as we were writing earlier, the forward reaction. So that would be the forward reaction. So an increase in pressure, so now we're talking about pressure, an increase in pressure favors more or less molecules, while decreases in pressure favor more or less molecules. So you have to decide which one. So we talked about this earlier. So if I increase pressure, that means the container is smaller. So I would actually want less molecules. So then the opposite would be for the decrease in pressure, which means the container would get bigger. So I can actually have more molecules since I have more space for them. And then the last bit is to answer the actual question, and it's based on that information in the first sentence. So therefore, this reaction requires an increase or decrease in pressure to favor the forward reaction. So the forward reaction, as you notice, has less molecules. So I'm going to pick the one that's less, which would be an increase in pressure. And that's how you answer that one. If you have any questions, just email, or you can leave a comment on Google Classroom. Thank you.